Let's begin. Today is October 11th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 6, 9, 15, 18, 20, and 22. And the puzzle uses the blue verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A takes a look at our middle digit, the square digit, and will let us know whether its value is an even digit or an odd digit. Criteria card B will take a look at the 3-digit solution and will let us know how many of those digits are 3. Are there no 3s? Is there a single 3? Perhaps 2? Maybe even all 3 are 3. Criteria card C will take a look at the 3 digits, triangle, square, and circle, and will let us know which one is the absolute largest. Is triangle the largest? Is square the largest? Or is circle the largest? Criteria card D, again, will take a look at our 3 digits, triangle, square, and circle, but this time it'll add them up together, and the Turing Machine will let us know whether the sum total is an even quantity or an odd quantity. Criteria card E will take a look at the 3-digit solution, but this time it'll let us know a little bit about its structure, so to speak. Specifically, there are 3 cases. One where there are no repetitions, as in the example 125, or the 3-digit solution could be a double number, as in the example 112, or it could even be a triple number, as in the example 222. And finally, criteria card F, again, takes a look at the 3-digit solution, but this time it'll let us know a little bit about the ordering of the digits, from triangle to square to circle. Should the digits appear in an ascending order, meaning that they're increasing, as in the example 135, or should they appear in a descending order, or decreasing, as in the example 421, or should the 3-digit solution have no order? So let's take a look at this example of 231. Notice that it goes from 2 to 3, so it increases, but then it goes from 3 to 1 and then decreases. This shift from increasing to decreasing, or alternatively, it could be decreasing and then increasing, but it's that shift is that it's one way to define the 3-digit code to have no order. We've also seen puzzles in the past where we have consecutive equal digits. For example, maybe an example as 225. The fact that they're consecutive from 2 to 2, there's no change, right? So it neither increases or decreases. So that, again, when you have consecutive equal digits, is another way that you could expect a 3-digit code to have no order. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 6 criteria cards that we just discussed. And we're going to start off with an initial proposal of 314. So the first thing I'd like to test is criteria card A. Okay, so the Turing Machine does approve of my choice for square. I did pick an odd 1. And so, yes, the Turing Machine confirms that that middle digit, that square digit, needs to be odd. So let's go ahead and type that up in our notes. And we'll say that square is an odd digit. And of course, since it is odd, that means it can't be even, so we'll cross out both evens. And the next thing I think I'd like to test is criteria card D. Okay, so in this case, we are adding up all our digits. So in the proposal 314, let's go ahead and add them up. So 3 plus 1 is 4. 4 plus 4 is 8. 8 is an even quantity, but the Turing Machine does not agree with that. So it's letting us know that the sum total should in fact be odd. So let's go ahead and type that up in our notes. And that's in D. So we'll say that triangle plus square plus circle should be odd. And of course, since the sum total is odd, again, remember that we've already established that square is odd. So there are two possibilities. It could be that, well, triangle and circle have to be of the same type. So either they're going to be both even or both odd. Because in both of those cases, when you add two evens or two odds, that total does equal an even quantity. And if we add this middle odd digit to that even quantity, we do get a sum total result of an odd quantity. So we're looking at either an even, odd, even solution or an all odd solution. And let's see, what else can we say? Well, we do have criteria card C that would let us know which could be the largest digit. But I think what I would like to test most is actually criteria card E. Okay, so the Turing Machine does approve of my proposal. In this case, criteria card E. Notice that 314 has no repetitions. And so, yes, the Turing Machine confirms that we have no repetitions. So we have an all-unique solution. Okay, so let's go ahead and type that up. And we'll say that the solution has no repetitions. And, well, honestly, I don't think that really clarified whether we're dealing with an all odd solution or even, odd, even. All we know is now that, there are going to be no repetitions. Okay, well, that does it for this round. We did complete our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So again, we did not test criteria card B, letting us know how many 3s there are. We also have criteria card C, the maximum digit. And we also did not test the ordering of the 3-digit solution. So one thing that kind of pops up for me is I believe I recall a puzzle where, if we do have an all odd solution, there should be at least a 3. But I believe in that instance, if there is no 3, then that means you only have a single odd, because if there is no 3, let's see, how did the logic go? If there is no 3 and it's an all odd solution, you couldn't have a sum total with just a 1 and a 5 and an even. That wouldn't work. So if you had no 3, then that would mean you only have a single odd. That's very, just so intriguing in my opinion, that the fact that you wouldn't have a 3 would lead to that conclusion. So that would mean that, yeah, that middle digit would be odd, but either 1 or 5. Potentially, if that's the case. I'm not sure. I'm just recalling a previous puzzle, and that's how it worked out. So if that's true, could you have a 5? Could square be the largest? Well, I don't believe so, because if square were the largest as a 5, then that would mean that the solution would have, an even in triangle and circle. And in both cases, whether you pick a 2 for triangle and a 4 for circle, it would be no order. So it'd go from 2, 5, 4 or 4, 5, 2. And I don't see anything, again, assuming that there'd be no order, I wouldn't see any way to pick one or the other. There's no way to distinguish. So those would be ambiguous solutions. So I'm thinking that, yeah, square's not going to be the biggest. It's going to be a 1. And what really is going to tell us is the biggest is probably criteria card C, because now we're dealing with a 4 and a 2. And I'm sort of guessing that perhaps square would be that 1. So it's either going to be something like 412 or 214 is what I'm thinking. And so, yeah, let's go ahead and I'm going to choose 412. And let's see. Now the question is, will we be able to deduce? I think we may be able to deduce the no order, criteria card F, but I think what this all hinges on is the fact that there may not be a 3. So let's go ahead and test. Well, let's see. I'm even thinking, can we even deduce that there should be no 3? It all does hinge on that fact if there's a 3 or not. Yeah, I think, let's go ahead and test B. Okay, wow. So the Turing Machine does not approve of the absence of 3. So there's absolutely a 3. Wow. Okay. Well, that said, of course we can't have 3 3s, or can we? No, we already established definitively that has no repetitions. So yeah, so no 3 3s, no, not even 2 3s. And since it did not like the fact of the absence of 3, then there's definitely a single 3 digit. Okay, so let's go ahead and type that up in our notes, and we'll say that the solution, or actually, I'm going to say we're going to deduce that we do have a single, the solution. Let's see. Okay, there we go. Well, yeah, solution has a single 3. So, okay. Well, what does that mean? Well, it almost feels like you still might have 2 evens, but there's no way to confirm that. Now, the interesting thing would be, well, no, I was thinking maybe the solution isn't in an ascending or descending order, but you could still have, possibilities with both evens and both odds. So that did not help. Wow. Okay. Well, I guess the next best thing would be to test criteria card C. Okay, it also did not like the fact I did choose 4 as my largest digit. Obviously, that is not true since the Turing Machine does not agree with that. So it's either going to be the square or the circle. So let's go ahead and type that up in our notes, and we'll say that either square or circle is the largest. So square Yeah, just experiencing a little bit of lag here. Or circle is the largest. Yeah, I'm experiencing a little bit more lag than usual. There we go. Okay. Okay, so that the fact that there is a 3 definitely put a monkey wrench in what I was thinking. So let's see, what else can we say? How can we deduce this? So just trying to figure out how to correct my error, because I'm still debating whether there are evens, it's even, odd, even, or all odd. What is our clue to that fact? How can we... There just seems to be too many possibilities where there could be no order. How could we... Yeah, even no order or ascending and descending. I just don't have a clear picture of what it could be. So we definitely have a 3. So there are no other 3s, but obviously we don't know where the only 3 goes. So I don't, well, it would be interesting if either triangle or circle were 3. But how can you know for sure? Wow. Okay. This is interesting. No repetitions. Okay, there is a 3, but you could still have 2 evens. The only thing so square word 3, it couldn't be the largest, because then you'd have a 1 and 2 to pick from, and that would not give us an odd total sum. Obviously 1, well, yeah, that's just the biggest. And again, I don't think square could be 5, because that would definitely have to be a no order, and you just have way too many possibilities. So I think we can exclude square 5, but I'm not willing to cross it out just yet. But that's what I'm getting. Oh, wait. So I actually, now that I think about it, would the reverse or the opposite be true? What if square were 1? Again, there would be too many choices, right? You still would have, 2 and 4 to pick from, or 3 and 5 to pick from. So I don't think square could be 1 or 5, because all those solutions would be no order. And again, you have too many things to pick from. Now, well, what about so criteria card C would tell you which is the biggest. But again, yeah, so, again, if square were 1, well, it can't be triangle, that's for sure. So say it's circle. So it's larger. Well, you got so many things to pick from, 4 and 5, for example. And how would you choose between 4 and 5? There is no way. So I don't think it could be 1, and I don't think it could be, I don't think it could be 5 either, even though you could say it's the biggest, you still have too many options. So I'm actually, I am going to say that square is the largest. That square is 3. Because I don't see how it being 1 or 5 would help us to zero in on the solution. There seems to be too many ambiguous solutions in either direction. Okay, so that's 3, but that still doesn't tell us which one is the biggest. Or it doesn't tell us. Well, and again, like I said, 3 can't be the biggest. So I guess circle must be the biggest since triangle was not. But let's see. Yeah, I mean, you could have ascending, descending. If circle's the biggest, if circle's the biggest, it would be 4 or 5. But how do you distinguish? Because you could have, I guess it would, I guess it would be ascending. Well, okay. So I think it cannot be ascending, because if you said, the solution is ascending, you would absolutely know that circle is the largest, which would make criteria card C irrelevant. And similarly, if you said, no, it's descending, then triangle would be the largest. And again, that would make that card irrelevant. So we are looking at a no order. So I'm going to deduce that we have no order. Okay, so if it has no order and circle is the largest, how would you accomplish that? Should I not have crossed out the 1 and 5 in square? I don't see it. So that's odd. D, the sum should be odd. So it's either all odd or even odd, even. No repetitions. And I'm pretty confident that the deduction, which, by the way, there we go, finally. We got a error here. Let's see what's going to happen. Okay, I think practically no harm, no foul, but let's see. Yeah, we'll just add the D. Okay. I do feel confident that crossing out 1 and 5 makes sense. But at the same time, how do you accomplish this? Okay. Well, okay. I'm going to test, even though I deduced it, I'm going to test F and confirm that it's true. Yes, okay, it has no order. So now I'm going to a third round and I have no idea how to choose a proposal. I don't get it. There is a 3. Because how do you choose a well, so it has no order. If we say, well, if square were the largest with 5, how would you pick between 1 and 3 for triangle? Because it would be 1, 5, 3 or 3, 5, 1. That doesn't work. So yeah, square cannot be the largest, which leads circle to be the largest, which means that yes, square could not be 5 for that reason. But now how do you choose? There has to be something very wrong in how I'm seeing this. That's the largest. 2, 1, 4, 5, 1, 3. Okay, well, yeah, and yeah, you can only have 1, 3. You can't have 3, you can't have 2. It's either there or it's not, and it did not approve of the absence of a 3. So there's a 3. But how can... Okay. D. I've corrected for D. I'm anticipating there being a 3. And now, which is the largest? This is bizarre. Three, 1, 5. So the only thing I can think of is that it's going to be 315. If circle's to be the largest, there has to be a 3. Yeah, so circle's the largest. Well, 2. Yeah. Wow, okay, yeah. So the way I'm seeing it is picking where the 3 goes is pivotal. I think it was a mistake to cross out the 1. So I'm gonna, I think I'm gonna go to the third round, but what am I gonna test? The only thing I can test, or can I deduce that it's going to be 315? Because if circle is the largest, if I were to pick square for 3, then that forces it to be ascending. So that means square has to be a 1. So circle's the largest. Obviously, triangle and square are not 5. Well, what about 214? So it's the largest. So if circle's to be the largest, it can't be 1, it can't be 2, it can't even be 3. So could it be 4? Or perhaps maybe square is the largest. 351, 153. That's ambiguous. What if this is 4? 214. 315. Oh, but you need a 3. So, 3. Yeah. Oh my goodness. Yeah. So I'm going to say the solution is 315, because if we needed a 3, if it was a 4 and we needed a 3, it couldn't be in square 3, because none of the triangles would work out for a no order. So that forces circle to be 5. And again, 3 wouldn't work, because then that would be ascending again. So 315. I'm going to go with 315. This is by far one of the most either complicated or definitely challenging puzzle. Okay. So yeah, basically I'm deducing that circle is the largest. And yeah. Wow. Okay, 315. That is correct. That is unbelievable. Okay. Well, let's see. How did we do versus the Turing machine? We did 6 tests. So we did ADE in the first round, and then the remaining 3 in the second round. So let's type that up. ADE. So A was correct, D was not, E was correct. And then in the second round, I believe B and C were both incorrect. And F was correct. I have no words. I don't know This seems so complicated that I have a hard time believing the Turing machine did it in 6. I'm not sure what combination of cards it may have used, or maybe it's some sort of not an average. I'm not sure what the word I'm looking for, but it probably tests different things and somehow it comes to a middle solution. But how it did it in 6, I don't know, because the logic it took me to figure it out was so complicated. I just didn't see it. But that could be just my my lack of comprehension. Well, again, very interesting puzzle. How did you do it? Please add your thoughts to the comments. If you like the video, please give it a thumbs up, and please subscribe so that you don't miss out on any future videos. Well, until next time, have a great one.